All right. So my name is Dan Bidleman. I'm the president of the Jacksonville Linux Users Group, and today's presentation will be on building Docker images from scratch. So actually building the images, not just using images. I've just recently started doing this, and it's pretty great. You can build some pretty neat stuff and deploy it wherever you want and have it built out very consistently and do interesting things. And so that's what we're going to be going over today. So I've made a couple of examples here. What I'm actually going to do, I was going to try to do a MediaWiki one, but I kind of ran out of time. And I'll do that one later. I want to build my own MediaWiki one. MediaWiki has its own, but they have I don't like how some of the stuff is designed. Like I don't run a big wiki page. I'm actually going to be phasing my my website back to MediaWiki because I really don't like the the GitHub uh, web page thing. It's more of a blog than a informational site. So it doesn't have a lot of things like code blocks, or at least it doesn't have. I think it has code blocks, but it does weird stuff, and I don't really like it. I can't do like tables. I think that's what the big qualm was. Um, so at some point, I'm going to build my own, and one of the reasons I want to build my own is just because I don't have a big wiki. I like using um, I think it was NoSQL. It's a I can't remember the name of it. I think it's NoSQL. It's probably not NoSQL. It's something else, but it's not a database. It's more of a file, um, and it makes it just easy to back up and manage. And it's just it's not really a database, and it's not good for like big sites, but mine's not a big site. Mine's just me and anybody who wants to look at the information I put up there. So at some point I'll get through that. But the presentation I built is based on ZNC. If you've never heard of ZNC, it's an IRC relay proxy kind of. And so the idea with ZNC is you have more or less a proxy client in here or a IRC client that connects to your server. So for instance, we're on Freenode. I'd have it connect to my or the JaxLUG and Debian and Gentoo in in Freenode as my user using my credentials, and then what it does is it stores. It sits there online and it stores any chats and stuff that go by. And that way, if I go and I want to use it on my phone, and then I want to use it on my desktop, and I want to use it on my laptop or whatever, I'm able to just kind of move between those devices and not, just lose bits of chat because IRC is ephemeral. It doesn't save anything. When you log off and you log back on, all the stuff that went on when you were logged off is gone, right? You don't see it because they don't provide you with that service. And so that's what kind of ZNC is doing, is it's providing yourself with that service. And so it was a neat little thing to build. Now, I built this just because it's a simple service. There is already a Docker. There's an official Docker, and I'll go through the code of this as well. There's an official Docker, and then there's also like a Linux server one, and then there's probably others. And then there's even a Docker file within the code, the source code that they provide you, which is really cool. So we'll look at the one that I built, and then we'll look at the other ones that they provide as well. Huh. Apparently, SQLite. Thank you, no proto. Yes, so SQLite is the database that I enjoy using, and apparently ZNC has been modernized by the Lounge, which I don't know if the Lounge is a new, is it person or a new package or what? But yeah, so maybe it's even better. That's great. So let's take a look at our file. So a quick overview. Docker, um, really it's not exclusive to Docker, but containers, the way that they work is you have an image, and you can think of an image like a CD image, right? You don't write to it, you just read, right? And that image contains everything that you need. And then you have a container. And the container is you run that image, and then you make changes to the container, and you can save those or don't save those. And that's what you run and use. When you remove the container, you remove all of the data that was in the container previously, and it's all lost to you. So that's keep that in mind when you're building stuff. You need to link it back, or you need to save that data off before you remove things. The way you update Dockers, and I've gone over all of this stuff in that other presentation I was mentioning. The way you actually upgrade a container is you delete the container, you update the image, and then you build a new container. And so everything that was in there that you don't have mapped out to volumes or saved off in some way is gone. And that's the only way to really update them. It's almost a violent update. You literally destroy everything and rebuild it from scratch. But that's how containers are. Like that's how they're idealized. So today we're going to build one. So this is it's a very simple container. It only has 4 layers, and I built this, not too long. It didn't take me too long to build this. It works really well. It's very consistently working. I learned a couple of things about Debian. Apparently, they're changing some stuff, and I'll go over that too. So, in this container, a comment starts with a pound sign, just like you would in most like bash scripts or whatever. I want to import some kind of a base, right? So my base image that I chose for this is Debian testing slim. Because I'm using Docker, it defaults to using Docker registry. And so when I say Debian, it just goes out to Docker registry and says, hey, do you have a Debian? And it's like, sure. And then I tell it, I want you to use the tag testing-slim. Testing-slim is the testing distribution, but without a lot of the packages, right? So it's very slimmed down, which is what I want. I don't want any cruft. Like I want the most base image I can get to start from, and then I'll add what I want. So yeah, that's how I roll. So that's why I like Gentoo as well. Is just I like starting from a low point and working my way up. It's very good for security specifically as well, because the less you have on the box, the less you have that can be exploited. And it also reduces the complexity of the box, which allows you to have things work more consistently without having weird things go on. So when it pulls this, now it has this first image. The next part is I'm going to go ahead and update it and install some packages and build a user. All right. So I found this one out because debconf gets real angry when you're not a VT100 based terminal, i.e., this is non-interactive because you cannot interact when it's building this thing, and so it will just yell like, "Hey, this is not an interactive shell. What's going on?" So if you give it an environment variable, that's what's going on here. If you give it an environment variable and Debian front end is non-interactive, then that basically just tells it, hey, this is not an interactive shell. Don't complain about it. Also, these are special words here. So from, env, run, user, workdir, run, entry point. These are all flags that Docker uses to identify what you want it to do. You can do multiple runs. As you can see here, I actually do multiple runs. You could do multiple environment variables. You could do multiple users. You can do multiple different things. And it basically walks down the Docker file and executes things. Every run, every from, I don't know about like workdir and those might not be their own layers, but every run is its own layer, which means that if you've ever used Docker and you download something and it's got like 100 layers, it's because the people don't understand how to make a Docker file. You have to basically make a gigantic one-line shell script to reduce the number, or like basically pancake the number of layers, because every single run is its own layer. And that can be very good, and it can also be very bad. If you have a huge number of changes that are happening to build this image, having all of those as layers is probably not great, because the person at the end has to download every layer separately. But having certain things that may change often in their own layers may be really good on the other hand of that. So let's say that you have an image that's being built and one of the layers is 2.5 gigs, right? Now that's huge. And if those people have to rebuild or re-download for any time it updates, they have to re-download the whole image, right? So if you have, let's say, a 3K thing that needs to happen, but it happens often, and that 2 gig image doesn't change very often, well, maybe it would be better if you do the 2.5 gig or whatever large part of that image, you do that as its own thing, and then you do the thing that changes more often, like so let's say config files or something, like config file editing or something. You do that change as its own image. That way, instead of whenever somebody has to update, they have to download 2.5 gigs, they only have to update and download like 3K, which is nothing comparatively. So it's you got pros and cons about how you do different things. And it can make it really messy. It can also make it very efficient, depending on where you're going and what you're doing. So up here, we're dealing with the Debian front end. I tell it to run, and then I say echo updating Debian, right? So that's just a note to the user that's doing the build. Hey, I'm updating Debian. It's just a little say hello and do stuff. I only did a couple of these, but whenever I build Docker images, a lot of times I'll litter them with echoes and be like, hey, I'm doing this, hey, I'm doing that. And that way, if it breaks at some point, I can go in and be like, oh, it said it was updating Debian and it exploded. Let's go look at that part and see what's up. Maybe like we lost network access. Maybe it broke something. Who knows? So, sure. Is that better? Cool. I'll make sure everybody can read it. Let's see. Yeah, I'm looking at it real quick. So the question is, how do you find the source Docker file? A lot of times, and we'll actually be looking at that in a minute. So we'll get back to that question. But for now, let's walk through this. We'll do a build, and that way everybody knows what's the base, like how to do this. And then we're going to go look at GitHub and Docker and everything. GitHub and Docker are actually pretty intertwined, and so you'll actually find that they're transitioning between those two a lot of times. But I don't believe the people have to provide the Docker file. They have to just provide the image. And so it's kind of up to the developer to provide that material. So that may not be something they provide all the time, but we'll see those in the Docker files when we start poking around with the other ones. So in this one, I say run. Okay, now it starts as root in this case because the Debian testing slim image starts as root, and as it goes down, it just uses the user that's in the previous thing. When we switch over later on, all the rest of the stuff will be that user. So I say I haven't changed the user, so it's root. I say I'm updating Debian, and then I say apt-get update. Now I usually use apt because it's a nice little wrapper for apt-get, and I don't like typing, like -get every time. And it actually warned me, like, hey, apt is unpredictable. You should use apt-get when you're scripting, which it was interesting to me that it knew it was in the script, and it told me a warning. So I was like, sure, let's go ahead and switch that to apt-get. So apt-get update, apt-get install apt-utils, because it actually complained about not having apt-utils when it was doing converging, well, not converging, but when it was installing packages, it would be like, hey, I don't have apt-utils, so I'm not going to do this in a nicer way. I'm going to do it in the whatever other way. So go. What comments? Yes. So what I did is I iteratively built this thing. I built the whole thing how I thought it would work, right? And then I would build it, and it would blow up, and then I'd be like, okay, what broke? And then I would fix it, and then I'd run it again, and it would blow up something else, and I'd fix that. And so that's basically how I kind of built this thing. And it's it's an interesting way of fixing stuff. But yeah, that's more or less how I did it. And I mean, that's a lot of how people code for the most part. Like you build something and you're like, everything should work. And then what do? You run it, maybe run it through a checker, or you compile it, make sure that it does what you expect it to do. Maybe you should put it through like other tools that help check it out and everything. This one I just kind of walked through and debugged it by just building it, running it, seeing what happened, looking at the logs and be like, oh, that's not right. Let's fix that. And that's how I did some of this. So we did the install the apt-utils, and then this is another one. When I was poking around, I actually found. Remember, this is testing, so this is a very new version. This might not apply to normal Debian, but full upgrade is now a thing. I've always done dist upgrade, which is forever ago, and I don't even think that's an option anymore. It seemed to take dist upgrade, I think. I don't really remember, but yeah, full upgrade. So now there's upgrade and full upgrade. Upgrade upgrades the packages without removing anything, which that doesn't make a lot of sense to me why it would do that. Their stated reason is basically so that things that are running currently can continue to run and still have the backend stuff. And it's like, I get that, but it does that anyway. It's kind of a known thing with Linux where it's just like when you run something, like if I update a package, right, and it needs a new library and it updates that library and nothing else, like all the updates don't need the old version of the library, but I'm still running, say, Firefox and it's using that. Well, that's Firefox is the old version of Firefox and it's using the old version of the library, but they're both running in memory. So when I restart that process, it'll start with the new version of Firefox that wants the new version of the library. So I really don't care that it's still on disk or not. I don't know. I guess you could maybe run into some issues if like some memory dumping happened or like something. But it's just like, you know what? I would rather, the thing clean out the system. And so that's what full upgrade does. Full upgrade now goes and deletes, it removes the old packages after it's upgraded the new packages. So interesting. Now I'm going to do full upgrades. And maybe that was a behavior before. Is like they just changed this from dist upgrade, or I don't know. I've just never seen full upgrade before, and it's been, it's interesting, the difference. So after I do upgrade, because this image is probably pretty up to date, but it's not probably completely up to date. That's why we're doing the update and then upgrade. And then these things I wanted to use, or I needed to use to compile ZNC. So wget I was using to get it. Build essential, libssl dev, libperl dev, package config, libicu dev, and cmake were all, which I'm kind of surprised cmake was not part of build essential. But yeah, I needed all of those to grab it and then compile it. I pulled that information from ZNC site because they're like, here's how you compile it. Here's all the things you need to do compile it in Debian. And I was like, fantastic, thank you. So after we've gotten and installed that material, then I say, I want you to build a user. Now note, I don't give it a password because I don't need a password because we're not actually logging into it. It's just running. If we do want to log in, it just drops us into a shell. It doesn't actually care, what user it is. I don't have a root password either, so you can't really become root. I could go in and manipulate sudo errors so that this user can sudo root, or I can potentially run a root shell, force a root shell into the system, or like give root password, or there's a bunch of different things you could do. But in this case, I just want to build a user so that I drop this thing in. Again, there's other Dockers. I'm just doing this one as an example. So I'm just building as a user called ZNC. The flags for user add are m creates the directory and builds the scale contents, the etc scale contents. It drops that into the user directory, so the user has like its bash rc and its bash history and all that kind of stuff. The C is a comment, and I just called it, like told people it's a ZNC user. D is the directory. That would probably be the default directory, but I just want to make sure that's where it is because I'll be calling it directly later on. Bin bash, again, is, I don't know what Debian defaults to, but it's probably bin bash. It might be bin sh, but different versions of Debian, or different versions of Linux use different shells, but I want to use bash, so I told it, hey, use bash. And then I called it ZNC. Now, at the end of each one of these lines, you'll notice that I have a backslash. Well, that in bash means a continuation of the line. And so I say, hey, I want to run apt-get y full upgrade, next, new line, and then it runs the next one. Okay? That's how you stack these things where you don't have a whole bunch of runs. If I didn't do that, I'd have to have another run here because it'd be like, what do you want me to do with this? I don't understand this because it's not intelligent like that. It's just, it does exactly what you tell it to do, which is how computers work. So the next section, I want to be the user. So I'm done with being root. I want to be the user. I want to do stuff as the user. So I run user ZNC. This is a Dockerism. This is a Docker keyword, and you're just telling it, hey, run the next steps as the user ZNC. All right. So it basically effectively used as ZNC inside of the container, or inside of the image that is building. Then I want to tell it, hey, workdir is home ZNC. What that means is it's workdir, I believe it usually just starts at root, so just slash. And I'm telling it, hey, I want you to actually start in ZNC's home. So that's why I put the workdir there. Then I have my next run statement. My next run statement says wget. I want to go ahead and pull the ZNC latest, so this is the place for it. Next line. Now I want to extract it using tar. And so I just untar it. And then the next line. I cd to Z and Z star because it actually has a uh, identifier for the version. So I think it's like ZNC-1.8.1, something like that. And so since I don't want to code the version in, I'm using the latest. I want this to be kind of robust, so I don't have to come in here and change anything when I want to update something. I just say cd2 ZNC, whatever, and it'll get there. Then I make a directory called build. This is what they suggested. You don't need to do this per se, but they suggested it, so I follow their suggestions. So I made a directory called build. I cd'd into it, and I run cmake on ... So that's the previous directory. So it cmakes the directory right above it. And then because we're not running this as a root, we're doing this as our user. We need to tell it where to put it, because usually it would put it in like user local. Well, I'm not root, so I can't write there. So dcmake install prefix home. And so this thing will actually build its own bin directory underneath this. I was doing like $home/bin, and it was making it under $home/bin/bin. And it's like, okay, all right, whatever. So it makes its own binary directory for some reason. So I just dropped it to $home. $home is equivalent to tilde. So if you ever use the tilde, like cd tilde or anything like that, you can also cd to $home. It's the variable equivalent. Tilde is kind of I guess it's just a shortcut to the same material. It might be a bashism. I'm not sure. Anyway, so cmake, I guess, configures it, and then you actually do your make. I did a make J4. The J4, for anybody that has done their own kernel or has played with C at all, or Gentoo. The J is a GCC build flag, and it tells it how many jobs to start. And so I have 4 processors on this VM, and so I told it to make J4. And so that it has 4 threads, basically. It starts up 4 processes, and as the thing builds, each task gets its own process, and it speeds it up quite a bit. And then I tell it make install. And because our cmake told it to go to our home directory, the make install will place that material where I told it to. Otherwise, it should actually end up in this build directory. We should see the ZNC executable get built in the build directory via this make right here. So you don't have to do make install, probably, but it does put things that put them into the places they're supposed to be. So potentially, if it's not fully contained, you may need to run that so that all of like any libraries, anything gets placed in the right places. Then down here, we have entry point. Now I've used CMD or command to provide this same functionality. You can do it with command or entry point. And I did a little reading, and entry point is what some people prefer because it is immutable, kind of. It's basically with command CMD. What you're doing is runs when you're building the image. CMD and entry point run when you're building the container. So when the container starts, I want to run ZNC. I don't want to run it when the image is building because, well, I don't care. I don't need it running when I'm building an image. But when I build a container, that's what I want it to do. All the image stuff previous is setting up for this. Now, command means that if I run the container and then I run a command after that, so I say exec whatever, it will not run what command is telling it to do. It'll run the other thing instead. Entry point will run both, I believe, but it will actually do whatever you're trying to do and then potentially more. But you will have to give it a special flag to not do the entry point. So it's really, and since this is built to do this, I wanted to run that. So another thing is this is built as an array. Command you can build this as an array or a script. Also, same thing with command. I don't know if you can build command as an array, but you can definitely do it as an exec script. You'll see that I run the ZNC here, and then I do a -F. The -F foregrounds ZNC, and that's important because apparently if you let it background, it just says, okay, I'm done, and kills the container. So you have to have something running to have the container continue. And in this case, it's ZNC. I want ZNC to continue to keep the container running until it dies for some reason, and then the container can just die on its own too. But that's important to make sure that whatever process that you're doing is kind of keeping the container busy so that it doesn't just stop. I also had attempted to get ZNC configured inside of the, build like a basic configuration. But ZNC is surprisingly really picky about its configuration file. I tried a lot of different ways, and it was never happy. I tried to even give it the specific input it wanted in its configuration builder, and it still wasn't having any of it. And so I was just like, meh, and just built I have ZNC running on this VM as well, and I just built the config, and then I'll show you how to link in volumes, because that's really kind of how you want to do it anyway. But in this case, All right. So, doesn't look like we have any questions. So let's go ahead and quit out of this. Look at my README here. Let's go ahead and build it. So if I do a Docker image list, you can see I have no images right now. I wiped everything out. And I could Docker ps -a. It gives me all the containers. No containers. Cool. So we're starting from scratch. This is the command I'm going to be running to build it. So Docker is our base command, and then you give it commands, right? So build, image, ps, those are all commands. In this case, we want to build an image. So we're going to do Docker build. I'm going to tell it -F and then the file. If I used, I think Docker file is the name of the file with a capital D. I wouldn't need to do the -F, but I like doing that. So I named my Docker file what I wanted to name it, and I told it, please use that. Then we have a tag, so -T. You can do multiple tags, and I want to call it Debian ZNC. Now, this is going to make a local image. I could also tag it with a URL for a registry, and it will still make it a local image, but then when I do a push, which I'm not going to be showing, I could push it to a remote registry, and that tag would kind of carry it along. And then I have v01, or 0.1. I can put anything in this. This is the tag. I can name it whatever. So this is the image name before the colon, and then the tag after the colon. And so a lot of times you'll have versions, and then you'll also tag the same version as latest, and I'll show you how we can change that after. So like when we're happy with the version, so let's say we had version 1 and we had version 2, and we're working on version 2, and you want to release it so people can go screw around with it, but you don't want everybody using version 2 because it's kind of broken. And so what you would do is you'd have version 1 in the wild, and then you'd have latest pointing at version 1. And then you could also have version 2 in the wild, but most people should be pulling the tag latest. And since they're pulling that tag's associated with version 1, and they're not going to get the half-broken version 2 until you're done and you're ready. And then once you're like, okay, everything's 100%, let me go ahead and re-tag version 2 to latest, it'll delete the latest tag out of the repository, and then it'll make a new latest tag that points at version 2, and then anybody that goes and refreshes their container list would then say, oh, I have a new version, let me go download that and install it. And then the dot tells you to just build it here, I think. You need the dot. I'm not 100% sure why you need it, but you do. So we'll run this. Here it's going to go. It's downloading Debian Testing Slim. It runs. So this is its own environment. So each one of these keywords is its own thing. I'm just going to scroll up so we can look at these. So you have step 2 is 7. It runs this environment variable. Step 3 is 7, and you can see that it's crushed all of this together. It's going to update and do all this kind of stuff, and then it's running that in this container. So you can see that each one of these is an image at least. But it's building them in a container. So it builds a container, runs its thing, builds an image, moves to the next step. So it installs the app utils, and then here's the thing I was getting that was saying like, hey, you should install app utils. And it does a pretty good job coloring things too, which is nice. And we come down here, it installs, I had told it to upgrade, so it upgraded here. And then I told it, hey, I want you to install a bunch of other packages. And so that's this right here. And it goes through, it fetches all the different stuff. Then it unpacks all the different things. And then it starts setting them up, building them out. Little apt errors as you do. Then it's done with that section. The next section is user ZNC, so it changes the user ZNC. Then it changes the workdir. I don't know if I can crush these down into one or not. It'd be something to look up. And then the next step is to do our big install. So we're going to grab this stuff and make the material. So you can see here it went out and grabbed it. And then it says, all right, I'm going to go ahead and start compiling. So it does its CMake, and then it does the make. And so we had 4 processors working on this, and they finished. And then I ran the make install, which actually it builds the modules. So yeah, you do need to do make install. Builds the modules, and then it drops them into the particular areas. In this case, we're installing it into quote home, and so it made a shared directory in CNC, and it sticks a bunch of stuff in there and include. So it's a little messy. We should have probably put it into like the ZNC directory or something like that, and then it would have had a bin there. And so there's a bunch of cruft rolling around on the user's home, but this is a demo. And then it says, hey, you've successfully installed. You can run this to make a configuration. Cool. We tried doing that, and it was really irritating, so we stopped doing that. And then it says, hey, entry point, that. It runs it, but it doesn't actually do anything because it's not executing that into a image. So if we go look at our Docker images, there's images and image lists. They do the same thing. You can see Debian and then Debian ZNC. Debian is the image we downloaded from Docker. You can see it was created 8 days ago. That was on their end. It's only 71 meg, right? So that's the whole operating system. That's what I like to see. I don't like to see, my operating system is, a couple of gigs. That's ridiculous. Let alone Windows at like what? It's up to like 30 gigs for the initial install or something. I don't know. Yeah, it's. I don't know why it's that big. I guess uncompressed pictures and stuff. I'm not sure. But I mean, this has no UI or anything. This is a server this is an image that's doing a specific thing. So I'm sure you could get Windows down to very small, or pretty much any version of Linux or Mac or anything. You could trim out a lot of stuff. This is about as slim as Debian probably can get. So 71 megs, that's a lot of floppy drives. I remember when I first installed Debian, it was 4 floppy disks. 4 of them. That's it. There's probably people that did it before me that it was less. But now that would be like, I don't know, a lot. It'd be like 60 of them or something. Um, and then this is our other one that we did, and see that it's 546 meg. Well, we updated, we installed some utilities and stuff to build stuff. We could potentially have like built it and then removed those to clean up, and then told app to like clean up stuff, and maybe made that image a lot smaller. But again, this is just a demo, so we're just shooting from the hip. So at this point, I want to run it. I want to see it do something. So if I do a docker ps-a just to see if I have any containers just hanging out, I don't. That's good. I did encounter, like when I was doing builds, that some containers, like if it would break, it would make a container and just the container would die, right? And so it'd just be hanging out here, and you need to get rid of those. So, yeah. The next thing I want to run is my run command I built. I also have a Docker, well, in my other presentation, I went over Docker files, or Docker compose files. And since I've already been talking for 50 minutes, I think I'm not going to go over that again. So this is just a simple run, right? So I'm telling Docker to run a container. I want you to daemonize it. So I want you to put it in the background because I don't want to see it running. I want you to name it ZNC just because why not? You don't have to name it. The -v, this was kind of my workaround for having the ZNC directory, right? ZNC directory is where all the config and everything is. So I just made a demo config on my box and then stuck it in the same place, and then we're just linking it into the container we're using. And then the -p is ports, and these are source and then destination. And it should be source and destination. And then what we want to do. So in this case, Debian ZNC version 01. Cool. Done. And there it is running. Now you can see that it is forwarding a port for us, and it's running the command that we want it to run. And we can actually go poker ZNC thing now. And I made it just admin, no. All right, and now there I go. Fully compiled, everything, I can do whatever I want. Yeah. So, and I'm planning on doing this for like my MediaWiki page and different stuff like that. But it's really cool because you want to do an update, you just run your Docker thing again, it builds a new image, and you just deploy that out with whatever tag you want, and you can stick on a particular tag if you want to have that particular version, or you can do different branches of things, and then have like latest be pointing at a particular branch, but then like people can use other branches if they want, or you can have branch like latest v4 and latest v5 and do all that kind of stuff too. So it's pretty neat. All right, I'm not seeing any questions, so that is that build. I don't think, I've pretty much gone over most of like the container, the image. I didn't really go over login, but you guys can do that on your own. Login is required for like doing pushes. So if you want to push an image up to Docker registry, or your own registry if you build one or whatever, you have to use Docker login to log into it to be able to give it the credentials and be like, all right, I'm me, and then now here's the image by doing a Docker push. Oh yeah, let's do a retag. Actually, I don't think I have it in here, but so if I do Docker image list, I can do Docker I think it's image-t, and then I'm going to tag that image as Debian ZNC latest. This guy. Nope. Let's see, what was it? I think actually it might be just yeah, it's tag. Let's see if that's right. All right. No image. Okay. There it goes. There you go. So now you can see that I have these are two of the same repositories. Now, when you're building a lot of this stuff, you would build it like if it's not for Docker repository, you would put like your own URL to your repository or whatever in there. And then I have two images here. And you can see that it's two images, but they have the same image ID, which means they're the same image, right? The image ID is the de facto truth, right? So you can see that these two are the same. That means they're the same image, but they both have a different tag. So if I installed with latest, it get that same image. If I install with v1, it get that same image. All right. So you can just add tags and then push up whatever tags you want. Now for the other Docker files, we'll just kind of go over quick so you can see them, but I don't want to be dragging it on for everybody. And so let's go ahead and take a look at those. So inside of ZNC itself, you can see this is just extracted. Okay, I've not actually run anything. I haven't configured anything. This is just what you get when you go to ZNC site and download their sources. You can see that there is a Docker file in here. There's actually a Docker directory, which I'm not sure what's in that. Nothing. Really? You made a directory, but okay, whatever. Well, this Docker file is quite a bit more complex than what I was doing, but mine's very simplistic. It also works in a very limited case. So Docker wants to use Alpine Linux, which I've actually seen a couple of times. I think Alpine Linux might be a very slim Linux, something that people will use, but they're maybe not used a lot. They'll use it for like automation and stuff, I guess. That's what I'm seeing, but I've never actually used Alpine Linux other than inside of Docker containers. So, and then they add some arguments, some labels. They do like a copy, so it copies, I guess, a directory to like that's sitting on your file system to this, and then it does some run setups, and you can see that they're using little backslashes. Backslashes just mean the new line again, and so this is all one line right here, effectively. This is all one line, effectively. Then it runs a script, right? So the entry point on this one is a script, and they have that sitting. Actually, it should be like right here somewhere. Entry point. I don't know. What was that directory they were looking at? Anyway, that's the one that's sitting inside of it. I didn't use that. I made my own, just to kind of show you guys. We also have one from ZNC inside of Docker itself. Now, I go to get, what I'll do is I'll say like, I'll say the name of the thing, so like ZNC Docker, right? And I'll say GitHub, right? And so a lot of times the people that are building these things build them in GitHub and then deploy them to the Docker registry, which was what NoProto was asking, where you wanted to say like, hey, I want to see how Debian Slim is built, and you could just probably do like Docker Debian Slim or Debian Git. and you might be able to find something. Although Docker Debian is a actual Docker one, it's not like a third party. That's not what I wanted. Docker Hub. So in this one, you might need to like kind of look around. There are these links to the different things, and so you can go like testing slim, and it gives you, yeah, here you go. This is, I'm guessing the Docker build for these guys, but you can see that it's from scratch, so it's calling a scratch one. So we'll have to go find scratch, add this tarball, and run bash in it, I guess. And so if we go up to maybe this, there's a scratch running around here somewhere. Yeah, I don't know. But there's apparently a scratch image. Maybe it's stable. Who knows? I'd have to go dive into it, and I don't want to bore everybody by like surfing around and being like, I don't know what's going on. Yeah, so you can look at these things in ZNC's Docker. You can see this, and remember what we were looking at previously. It looks similar. It's not the same though. Which is kind of interesting. I don't know why they would be different, but they are. It's using the same Alpine, but then it's using like this environment GPG key. It's doing the CMake flags and make flags the same way. It's doing a ZNC version here, but it's not over here, and like they're different. Why? I don't know. They're both potentially distributed by the same people. Not sure. And then there's also one built by Linux server folks. I've built a bunch of stuff from them, and they make some pretty good quality Docker images, and they keep them up pretty good. So here, these guys are using a specific Alpine version, so it's LSI O-base, and then their Alpine 311 as a build stage. And you can see that their build method is pretty different. And they're adding a bunch of, these are probably all plugins. Well, that's probably the ZNC source, but then you know, like playback tar and then push, and these are all probably plugins. We can go in and look if we wanted to. And so they're building a particular version, and so you can see everything that they're doing here. So it's proprietary by default? Kind of. It's kind of goes on the trust of whatever system you're building. I don't know about disassembling the image. You're running an image, so you can go into the image and actually look at what's going on. And I don't believe it's encrypted, and so you could probably deconstruct any image and potentially backport it. I don't know about getting this, which is like what builds it from whoever, but like you can see ZNC, it's not, and also like they're saying Dockerfile here, but it could potentially not be what they're building. They could just send you this and be like, all right, and then we used a different one and build it and send it up there. This GPG key may be something that helps with the signing or anything like that. So potentially they're signed. I believe that like you go to, like if you go find Joe Schmo that built an image, you might want to look at the image before you run it. Or if you just trust them, you can just do that too. Like it really just depends on what your trust level is. If it's little to no, you can build your own. You can inspect the images themselves and see what's inside of them and poke around and make sure that things look on the up and up for you. or do whatever you need to do. These this Docker file and the material that they send you are not necessarily the same thing. So again, it kind of comes down to trust. Like, do we trust Debian's package repository? Usually, it's had problems before, but I mean that's what the signing keys and all that kind of stuff are for. But sometimes those get stolen. I mean, it's very rare, but they do. And yeah, I don't know what that is, so I'm not going to paste that in there. But yeah, that's Docker files. So hopefully you guys enjoyed it. Yeah. So I'll go ahead and stop recording.